In 8.2, we're going to be talking about the focus of a parabola, which is just a specific point on the graph of a parabola. Our learning goal I will find the focus of a parabola, and also I will write equations of parabolas with vertices at the origin. So all of these graphs will be starting at 0, 0, or have a vertex at 0, 0, given the foci. So that's our plural of focus. Just like vertex, the plural is vertices. So same idea, we don't say focuses. So that is our learning goal for today's lesson. Starting out, you need to know what the focus is. And basically, it's just a fixed point on the interior of the parabola. So if we have a parabola like this, the focus is just a point inside that parabola, and the parabola wraps around that point. The focus is always going to be on the axis of symmetry. For the graphs that we're doing today, our axis of symmetry is going to be the y-axis, so our focus will always be on the y-axis, and the parabola is just wrapping around it. You could also have a graph that looks like this, then your focus would be on the other side of the x-axis because your graph is on the other side. Whenever we have a function that looks like this, y equals ax squared, where a can be anything except for 0, our focus is always going to be the point 0, 1 over 4a. This is like a formula, basically, that you have to know. I would put a big star by that. You have to know the 1 over 4a, and that's going to give you the coordinates of your focus. Our first example here is to graph y equals -1/2 x squared and then identify the focus. So let's make a table for our graph. Let's put in -2, -1, 0, 1, 2. -2 squared is 4. Half of 4 is 2. This is negative, so it'll be a -2. Just looking at that function before I even start, I know that because my a is negative, my graph is going to open down, right? And because this is less than 1, it's going to open, it's going to be a little wider than my typical x squared graph. So I'm just going to keep that in the back of my mind as I graph. If I put in -1, -1 squared is +1 times -1/2 gives me a -1/2. 0 times -1/2 is 0, and then because it's symmetric, that will just be 1/2 and then 2. So to graph this, I know that it's going to be in the bottom 2 quadrants because of that negative. When I put in -2, I get out -2. When I put in -1, I get out -1/2. Oops, symmetric, so those should be the same. So that will be 1 -1/2 and 2 -2. So my graph is going to look something like this. Of course, you can pick other points if you want. I just pick these ones because they're the easiest. So I did my graph. Now I need to identify the focus. Remember, the focus has the coordinates 0, 1 over 4a. A, in this case, is -1/2. That's the coefficient on my function. So 1 over 4 times -1/2 is what my y coordinate is going to be. 4 times -1/2 is -2, because half of 4 is 2, and this is negative. So the coordinates for my focus will be 0, -1/2. I can bring that negative right here out to the front. So that means that my focus is at 0, -1/2, which is right here. And you can see that it's on the same side as the x-axis as my graph, which is exactly where it should be. For these, try on your own problems. In your book it has you also graph, but I'm just going to have you identify the focus. So go ahead and try and find the focus, or the coordinates of the focus, for each of these, and then hit play and check your answers. Okay, so remember, for all of these we're going to be using 0, 1 over 4a for our coordinates. In this case, a is 2, so it'll be 0, 1 over 4 times 2, or 0, 1/8. Here, a is 1 over 6, so 1 over 4 times 1/6. And let's think about what that is. That would be 1 over 4/6, or 1 over 2/3. But we don't like fractions in fractions. So the way that I always think about this, it's 1 divided by 2/3, or 1 times 3/2, which is just 3/2. So we had to do some extra manipulation. It's not hard, you just probably haven't done it in a while, so you forgot all about how you can do that. So that this part became 3/2, so our coordinates are 0, 3/2, or 1.5. And then finally, this guy, our a, is -3, so 1 over 4 times -3 is 1 over -12. So the coordinates would be 0, -1/12. The next thing you have to be able to do is start with the focus and come up with the equation of the parabola. So we want to write an equation of the parabola with focus 0, 3 and vertex at the origin. This part is super important in one way, and actually not very important at all, because you have to know that the vertex is at the origin. Otherwise, this is not, our 0, 1 over 4a is not how you would find the focus. So this is there because otherwise you wouldn't even be able to find the focus at all. So remember, it's 0, 1 over 4a. So this 3 has to equal 1 over 4a. So I'm just going to set up an equation. 3 equals 1 over 4a. I don't like variables in the denominator. So what I will do is I will multiply each side by 4a. And that gets that variable out of the denominator because these will cancel. 4a times 3 is 12a. So 12a equals 1. Divide each side by 12. And I'll get that a equals 1/12. So then y equals 1/12 x squared, because remember, all of these will have that form. So it's really easy. You just have to set up an equation and solve it, where your y value of your focus is equal to 1 over 4a. Okay, so for the last example I'm going to do for you, this is just like example 3 in your book on page 413, where we have these microphones. They're called parabolic microphones, and that's because it's like a microphone with a hemisphere around it, or it's actually a parabola around it, and that directs the sound into the microphone, and so it picks up extra sound, I guess. So if you look, there's actually a picture of what one of these looks like in your book on page 413. But basically, if you were to slice it in half or look at a cross-section of it, it would look like this parabola, where this is the microphone right here, and this is like a plastic thing around the outside to direct the sound in. And the shape of this plastic piece actually is the function, in this case, y equals 1 over 30 x squared. It should look like this. The x squared is not down there with the 30. So that's our function. And the best place for the microphone is actually at the focus of that parabola. So what we want to know is how far away is the end of the microphone from the base. Or how long is this arm right here? This is called the receiver arm. So we basically just need to know, where is that focus? So if we're using y equals 1 over 30 x squared, and we know that the focus would be at 0, 1 over 4a, In this case, A is 1 over 30. So 1 over 4 times 1 over 30. 4 times 1 over 30 would be 4 over 30. And I'm going to do the same thing I did before, where I thought of this as 1 divided by 4 over 30, which would be the same as 1 times 30 over 4, which is just 30 over 4. And now that will simplify to, let's see, 4 goes into 30 7 times with 2 left over. So that will simplify to 7.5. So if we're thinking about this whole thing like in terms of inches, then this is at 0, 7.5, which means this receiver arm is 7.5 inches long. So look in your book at example 3. It'll do a similar problem with different numbers, but really we're just using that 0, 1 over 4a over and over and over again in this section. So do your best. Your homework is on page 414. And you're going to do numbers 1 through 3, 8 through 20 even, 13, 27 through 30, and 31 through 34. So go ahead and hop to that, and remember, you're going to have to know that 0, 1 over 4a. You have to have that memorized. So write it down every time that you use it, just so it really sticks in your head for the quiz and for the test.